Okay, so this is where we got up to last week, talking about partitions on drives. As I said, the reason we do this, a few reasons actually. Number one is the efficiency in dealing with separate partitions. If you have a separate drive or partition for your operating system, you can be reading stuff for the operating system. Another drive, at the same time you can be writing out data from the to the user directories. But also importantly is when you're doing the backups. If you separate out your file system, you can have a more efficient backup, and backups can take a hell of a long time. Data's getting big and bigger. Tapes are still very slow. Network storage is still fairly slow when you're dealing with large amounts of data. Even the 1 gig, 10 gig Ethernet speeds are still relatively slow and time consuming. So splitting up the operating system makes sense. You're not going to back up the operating system itself where you install your Linux or Windows operating system, because it doesn't change. If anything goes wrong there, that drive dies, you usually do a reinstall anyway. So there's not a great deal of use backing that up. Places that store your log files, generally you wouldn't back those up either. Spool directories, print jobs and those sort of things, again you wouldn't back up, so put them on a separate partition. Using a separate drive for swap space, the virtual memory, is also a good idea for efficiency, and again it breaks it off so you don't have to back it up. User applications, again, change rarely, but you probably want to back that up rather than having to do a reinstall each and every time it dies. So you would probably back up your applications directory, but that's very dependent on how it's installed. So if you look at a local software install for Microsoft Office, for example, it actually alters the operating system, which is a really bad thing for it to do, but it does. So when you back up the applications directory under a local install of Windows, generally you can't just restore it. So bear that in mind when you're creating your backup schedule. If you're going to have those sort of backups done, you're probably going to have to back up the operating system and the applications together. And then if you do need to recover, you'll have to recover that whole thing, but generally that's not a nice way of doing things. Under other operating systems, you can separate out the applications and the operating system itself, and therefore don't back up the operating system, back up your applications, back up your user directories much more often, and don't back up your logs, etc. Okay, so when you're creating this, it pays to split things up as we describe here. Unix and Unix-like operating systems have naming conventions, and we'll have a look at a couple of examples of that. And you should stick to these as much as possible. As I said, it makes it easier to locate things, it makes it possible for users to locate the applications they need, where their home directories are, if you stick to these standard conventions. More importantly, the other system administrators you're working with will also know where things are stored. And remember, whatever you do to the other system administrators, they are going to do to you too, so you try and play nice with them. And in most organisations, well, most larger organisations, you won't be the only person looking after the systems, you'll have others there as well. So having it in the right place makes it life easier for everyone, and you can work out where things are without actually having to ask the person who installed it. Okay. So you can structure the software. As examples here, we create subdirectories like use a local bin for local applications that we're installing, and again it has this nice standard structure so that you know anything with USR is for users. If you have an SBin, it's for your system administrator, so root accounts, things that have to do with running the services, creating users, those sort of things belong in an SBin location. You use a local directory if you're storing it on your local machine, and you don't use the local if you are storing it on your file server or your main servers. Some of the standard ones, and we went through these before. Bin is where you put your binary files for executable programs. These are the normal ones that people use. Generally to do with the inbuilt system utilities like org, grep, those sort of things. The utilities that you would normally use but are not specific to an application or a user. SBin is where you store the system administrator utilities like add user and other administrative functions, so it is actually separated off. You can then set the permissions so that nobody but the administrator group can get access to those applications. And that helps your security a little bit. Lib is for libraries and supporting files. Everything goes in lib files under either user or directly under lib. And as I mentioned, the etc is where we put all our config files. So if you're ever in doubt where the configuration for something is, it should be under etc. Now, who's done this sort of stuff on a Windows server before? No? It can be fun to try and locate it. We have something called DLL Hell under Windows, which is the dynamically linked libraries. These are chunks of software that perform a standardized function like the TCP/IP stack, for example. So if you're doing networking, so programs that actually run your network connectivity. Under the Windows operating system, when people write an application, they can rewrite the DLL and have that installed on the hard drive somewhere, anywhere. All right? And it can have the same name because it performs the same function, which means you can have multiple versions of these dynamically linked libraries scattered throughout the drive and you don't know which one is the correct one to use for a particular application. This is one of the many reasons Windows got the reputation for being extremely unstable. It wasn't actually Microsoft's fault. I hate saying that, but it's true. It's the fault of the software developers. Right? If you don't write a good DLL and you overwrite the system DLL with your badly written one, you can crash the system because it might be a system DLL that's being used, like the TCP/IP stack. This also is true of device drivers. I might have mentioned this earlier. Device drivers, under the way Windows is designed, actually are fitted into the kernel. Remember, the kernel is that core of the operating system. It's the bit that has access to everything, talks to the hardware directly, etc. All right, so when you have a printer driver and you install it for your brand new HP printer, anyone who wants to buy an HP printer, yeah, horrible things, it installs into the kernel. Now, if you change the kernel, that is a bit of unchanging memory that is in control of the system, and if something is bad in this driver, it will crash the machine. So again, not Microsoft's fault. These blue screens of death were quite often from a badly written device driver. This was meant to be fixed with the registry in Windows 95. It didn't fix it, it just made it worse, because the registry then pointed off to all these DLL files which are scattered everywhere. Long story. It has improved greatly. You no longer need to have device drivers and these DLLs critical to the system, and user stuff is meant to be hidden off somewhere else. But because it is still, there is still a lot of legacy code within the operating system, you still can have these problems reoccurring with the mix of DLLs and device drivers interacting directly with the kernel. It's one of the best things that Apple ever did was completely scrap their OS 9, OS 7. Anyone old enough to remember playing with those? It's awful. I hated it. I detested Macs for that time.
Sure it's got like no memory section at all.
Yeah. Oh, there's lots of problems with it. And they started creating a new operating system called, beginning with C, and I can't think what the name was. Spent millions and millions of dollars on it, billions probably. Almost went broke, gave up, and bought Steve Jobs back in with Next, the Next operating system, which was basically a flavour of Unix. Well, it was a framework that sat on top of Unix, Linux. Yeah, and they completely scrapped all the money they put into their operating system, started from scratch, and rebuilt it on a nice, solid, stable foundation, which was BSD Unix. Microsoft have never done that, by the way. So there is still, and I know the software engineer who writes the protocol stack and the software within the operating system for Windows over in Seattle, and he says there is still 16-bit code, this is from the old DOS days, residing within the TCP/IP stack under Windows software. You can understand why they do it, because it's really expensive to throw everything out and start again. All right, so anyway, bit off track, but Windows does things differently because of this heritage that they've got. Under Unix or Linux operating systems, it's based on stuff that was on Super Minis, was designed to be used by multiple users, was therefore secure, and everything was sandboxed out so you couldn't interfere with the kernel. So back to what we were talking about. Here's an example of a file structure you could set up for your file system. And we have something called user local bin, user local, which is pretty standard. And under there we have our bin, lib, etc, sbin, share, etc. directories. All right. Also under the user local bin we have our GNU GNU's not UNIX directory, and a site directory. All right, under the GNU directory, we've also got a bin, lib, etc, sbin, and share directory. Under the site, we've got a bin, lib, etc, sbin, and share directory. Can you see the problem here? Because everything is nicely separated out, but there's this plethora of bins, sbins scattered all over the place. Which means when you're trying to set up your path or when you're actually executing a command, you don't necessarily know which bin directory the executable that you are executing is in. So this is an overkill. This is trying to split things out too much. And again, even in the Windows operating system, when you're setting up your applications, etc., you do something like this, you should be very careful to stick to conventions. Another example which may be better is here. We have a site directory, we put a software directory underneath it, a local directory underneath it, and an admin directory underneath it. And within those, we have our bin, lib, etc, sbin, and share directories in each one of those. So we're making a logical partition of the kind of software and files we're storing, which assists us not only in backup, so we don't back this up, but we back the local up, for example, but for the logical arrangement of where the utilities and the programs are that each type of user wants. So when you're setting up your permissions, you give all of your users access to the local directory, and you give read-only access to the software directory to all of your users, and you give no access to your users to the admin directory. And it immediately takes out the access to all of those things underneath. They can't use utilities that they shouldn't be using. Now, that makes a lot of sense. And again, when you're setting up your Windows server, do the same thing. Different file names, different sort of structure, but you should set it up the same way. Keep your user data somewhere, keep your non-changing data somewhere else, your scratch, spool, log file data somewhere else, preferably on separate drives for efficiency, and it makes your backup and locating things and maintenance much, much easier. Okay, again, when you're doing your configuration or installing stuff, make sure that you are aware of the security issues. Some software in Linux and a great deal of software in Windows tries to install itself on top of the operating system. So it replaces chunks of the operating system with itself. Very, very bad thing to be doing for stability reasons, such as I said before. So if you have a device driver that's going to overwrite part of the kernel, that's really bad. Don't buy that hardware, don't install that driver, because it is not tested. One thing I don't mention here as well is the approved hardware lists. Something when you buy your whiz-bang brand new server, if you're unfortunate like us, you have to buy a Dell. It comes with a list of approved hardware, right, and approved software that can run on it. So if you're going to plug extra hardware in, they have run through testing and say this piece of hardware, this particular SCSI board, for example, will work under ESXi. We've tested it, it's good, you can use that one. If it's not in that list, don't use it, because it's untested and you don't know whether it's going to cause a problem within the system because of badly written drivers, or the way that they've installed the, designed the hardware itself. Yeah, so when you're looking at things like ESXi, you guys can get a copy of the software. It's worth $7,000 or $8,000, but you can get an educational copy off that store that I've told you about, the E5 on the hub thing. With that particular software, because it is a hypervisor, bare metal hypervisor at that, which we'll talk about next week, I think, or the week after. Not next week, next week's great again. Yeah, we'll talk about those then. It is very specific on the hardware it will run on. So you have to make sure that if you are going to run something like ESXi, which is a rather unique sort of operating system, if you can call it that, it has to run on particular types of hardware that's been tested. Otherwise, you will have problems. And in some cases, it won't even install. So when you get a copy of that, you can try and install it on your local machine at home, see what happens. And sometimes it'll work, sometimes it won't. So it's just something to be aware of, this hardware compatibility list. All right, so when you're installing software, make sure that you look where it installs. You can do this with make-n install. By the way, have we all used makefiles before? Anyone not use makefiles? Anyone just not feel like putting their hand up or admitting to anything?
Yes, sir.
If you're here, put your hand up. If you're not, don't. All right, makefiles are a way of compiling. Because when you compile something, it requires a lot of options. So you create a makefile which runs through all those options for you and builds things in places in the correct directories and then deletes all the old files and the object files and other things that are created in the process. So it's just a way of making compiling easier. And it has a few options. If you do a make minus n install, it'll just check the destination, tell you where everything's going before it actually installs anything. So it goes through the install process without actually copying anything in. This means you can have a look at it, and these are very, very verbose outputs normally from makefiles. So again, this is where you would want a script to look for particular aspects of the output. And it'll just run through and go through the process without actually copying anything on, and you can check to see things are going in the right place. It's much more difficult to do that under the Windows environment. You've just got to trust that the person that supplied you with the software is doing the right thing. Okay. All right, there's a few there, examples that are really bad. Sendmail and bind are really, really bad in BSD. They modify the operating system. And you should be using bind in one of the labs. Okay, and also, when you're installing, never work as root. Right? Never install anything as root. Because quite often what the application that you're installing will do is it'll look at the user that is doing the installation and install itself with those permissions. So if you've got a daemon that you're installing, say, bad one, FTP, and you install it when you're logged in as root, it will get root permissions, which means when somebody does an anonymous login to your FTP server, they may get root permissions on your machine as well. So never install anything under root, never install anything under administrator, on Windows. You can't install anything unless you're administrator under Windows. But be very careful of that situation and how things install. All right, one way we can improve the security when we're doing the configuration is we create users for specific daemons that are running in the background. So when you're looking at top, you'll see there's this whole bunch of services that are running in the background that have funny names. Under Mac you get Wheel. You'll find others that are Apache or FTP or other things. These services may require, you create an ID for these particular users and you assign the rights for this service based on what it needs. All right, so if we look at the HTTPD daemon, this is the thing that serves web pages out. So you're running a web server, you have HTTPD running in the background. When it receives a request via that IP address and port number that we talked very briefly about last week or the week before, it can then read a file off your hard drive, which is the HTML file, and send it out through the network stack on the HTTP protocol, which means it doesn't need a great deal of rights. All it needs is the ability to read that particular file. But for it to start up, it needs to get access to the network stack, which means it needs a very high level of priority. So these systems will start up, and normally they will install and remain this way, start up with a high level of priority. And what you then want to do is be able to wind the the privilege level of that service back down to what it needs. Okay, so, yeah. Okay, so this is the problem. If you install something as root, the daemons may actually start up and run as root, and then if you access them from external, you may actually get root access to the system because the daemon's running that way. All right, so generally we wind it back down, and we do that by using the set user ID programs. Okay, so we give a special privilege for a short period of time to the daemon as it starts up, and once it has started and it's in its normal running configuration, we can reduce that back down to low-level privilege. Now, on the Macs, if you fire these things up in Mac, you'll find that there is a user called Wheel that appears on the system. It is a very, very low privilege account. Under Linux, you'll find there's a nobody user, and nobody user has no rights, but it can be sitting there running as a service on the machine. And this is the way you can start locking things down. Look at ways you can take the users that are associated with the services and reduce the privilege for that particular one. Another thing you should do is, if you look inside your password file, have you all looked at the password file? Yeah, should look at the password file. I can show you later on if I remember. You'll find that there's a it's a fairly, actually it's in here later on. There's a standard format for it, but it also defines the shell that you give to each user. And I think I did mention this before about shutting down users. With your services that are going to run in the background, they generally don't require a shell. So make sure that in your password file you've actually removed the shell specification from that particular user. So if you have a look in the user, password file in etc, you'll see that the first field is this encrypted password, unless we're using shadow passwords, and at the very end is bin/bash or bin/tc shell or something similar. And that is the shell that is run by that particular user when they log in. If you remove that, it's still a user. They can still run executables, they just don't get a shell, which means if you log on, and this is probably a worthwhile thing to do, create a user, remove the shell command, log in as that user, and you won't even be able to log out because there's no command shell, there's no way of typing anything in. You have to actually just go and kill that process. Okay. Okay, and there's a couple of examples there. Apache uses a user www, and MySQL uses MySQL as its user. So one of the last labs you'll be doing on Linux is a kernel customization. This is a fun one because you get to see how small a kernel that you can build that will still function. Why would you want to do this? Efficiency, number one. Right, if you take out services that are within the kernel, remember the kernel has to reside in real memory. And real memory is still limited. Right? We can have 32, 64, 128 gig of RAM on machines, but it's still limited. Right? It's not in the terabytes. So your kernel takes up a big chunk of memory and cannot be taken out of memory. If you take it out of memory, the machine stops running. All right? So if you've got a really, really big kernel, then you're going to eat up a lot of the very limited memory space that you have. So first reason is efficiency. Real memory is something that helps the speed of the machine, the responsiveness of the machine, ability to run lots of other things. The second reason is security. If you have functionality in your kernel that is not necessary, it's also a way of breaking into the system. So if a particular service, say a USB utility, not utility, what do you call it? Something to handle USBs, it's not the driver, it's part of the kernel. And if your machine is not going to use USB at all, then why have support for it? Physically, the machine may have USB ports, but if you take USB support out of the kernel, the machine becomes incapable of reading anything you plug into a USB port. So in servers, this could be handy. Because you quite often don't have a keyboard or mouse on them. You don't even have a screen on them. If you look at the machines in there, there's no screens or keyboards on the machines in there, you do it all remotely. Right? And they run what's termed headless. Headless is just no keyboard, no mouse. Right? And you access them from another service. So again, if we go back to ESXi, nice little bare metal hypervisor, machine is running ESXi. Sitting next to it, you have a normal machine running vSphere, and vSphere does all the configuration on the ESXi machine itself. So you have a machine somewhere else, usually on the administrator's desktop, running vSphere, and it then talks to the ESXi server for provisioning of machines. Okay, other things, there's SpeakUp. One of my favourites, SpeakUp is a kernel modifier that takes your normal output from the standard in, standard out, and redirects it through a speech synthesizer and keyboard input, and interrupts the keyboard so the keys mean different things. But it requires a patch into the kernel because it's replacing the normal way the hardware interacts with the operating system itself. So you have to recompile a kernel to build that in. All right. Now, when you're doing the kernel lab, you need to get the kernel source, always, except in this case where we're supplying it to you, get the kernel source code from kernel.org, so it's a legitimate kernel. Remember, people go out there and they change software, particularly open source software, so that it has malware in it. That's the best way to break into a system, to get someone to install some malware. When you've got the kernel, make sure you keep the old kernel. Now, think when you last went from Windows XP to Windows 10 on your old machine. If it didn't work, your machine was dead and you have to reinstall everything if you didn't upgrade it correctly. Big problem. Under Linux, it's easy to go back to the previous version. And in fact, when you're running Linux or Unix machines in a production environment, what you will do is you'll have your test environment, make sure everything seems to be working. When you go live and you put the new kernel in, you keep the old one there. And it allows you to very, very quickly go back to different versions of the operating system if you discover there's problems. Right? And the way we do this is we set up something called a symbolic link. And if we use ln, which is link minus s for symbolic, it replaces the inode, which is on the file system, that points to the file that you want to use. Okay? And something like a shortcut on your desktop, but not quite. All right, so we can actually do this with the operating system. We create a symbolic link to the operating system we want to run. We leave the old operating system there, and if the operating system does something wrong that stops us from being able to work, we can quite easily go back, change the symbolic link to point to the old operating system and go back to the previous version. No changes. Right? Very, very simple, very easy to do, and when you're doing this in a production environment, very important that you remember to do it. Okay, how we do it there is shown in this bit of code. Copy the kernel image to the right place, or sorry, the old image to a renamed file. Copy the new image in, extract the image, the software out, and do a symbolic link to the new version. Okay, so when you're customizing it, one of the things you should be looking at is the architecture. Linux runs on lots of different architectures, so you've got to make sure you choose the right one. And more specifically, if you're installing on, say, Intel architecture, make sure you pick the right sort of Intel architecture. Okay, there's specific builds that are available for AMD or different versions of the Pentium processors, the i5, i7, etc. So there's different versions. Because each of the machines has a slightly different instruction set, it will optimize for the kind of CPU that you have installed on your particular piece of hardware. Generally, if you install the i386, okay, that's an old machine, isn't it? It's backward compatible. So i386 will basically work on any of the new machines, just doesn't take advantage of a lot of the improvements that are on them now. So that's always safe. When you're doing the installation or compiling the kernel itself, you've got to tell it what you want to include. And this is a really, really long process. There's a couple of different ways of doing it. You can do make. Remember, make is just a way of compiling files. Make config, which is a command line one, and really, really tedious, because it will come up with every single aspect, every module within the kernel, and ask if you want it installed, not installed, or loadable. And loadable means you can actually load it in during runtime while the system is up and running. Very good to be able to do this because it means you don't have to do a reboot. Going back to the old days of Windows NT, if you change the IP address because the network stack was within the kernel can't be unloaded, right? It always has to be there or the machine doesn't run. You had to reboot. When they changed to Windows 2000, they said they had reduced the number of reboots or the situations where you have to reboot by over 600 different configuration changes, but there were still gazillions of them. Anyway, there's a lot better now. But if you have something as a loadable module, it means you don't have to reboot the machine to change the kernel parameters. So if you're unsure whether you want something, have it as a loadable module. If you're sure that you don't need it, then don't compile it at all. And that reduces one possible vulnerability within your system by not having these services running. Okay, make xconfig requires X Windows. It's a little bit prettier, a little bit more graphical. Won't save you a great deal of time. And you have to have XDM installed and the X windowing system, which may or may not be there. In the case of servers, which is the most common place you'll be doing a kernel compilation, you won't have X Windows installed, so won't use that one. And finally, probably the easiest one is make menu config, and that just gives you a menu choice. Yes, no, loadable module. And that runs through. Okay. All right, xconfig requires X11, as I said, and that is a highly insecure system if you don't install it correctly or you don't have other things in place, so best not to use it. Okay, and capitalisation when you're doing the make menu means it's a default. Right, after selecting everything, and there is a lot to it, as I said, one of the nice things you can do is see how much you can remove and how small you can actually make the kernel. Fun little exercise if you're that way inclined, which I am. To build the kernel, we do a make dep, and this basically goes through and checks the dependencies. One of the big problems with open source operating systems is dependencies. You will have one package which depends on another package, which depends on another package, which depends on that first package we were talking about. And you can't install until you've got that dependency sorted out, which means you can't install at all because each one is dependent on each other back to the beginning. To check this, do a make dep, which just goes through, says these are the packages I'm installing into the kernel. Does it have all the dependencies included? And we'll check for you. And if not, it will then put those options back in for you. Well, actually, you've got to do it yourself. We then do a make clean, which removes all of the old files from any possible previous compilations you've done. If you don't do this, you may end up with some object file from the previous attempt to compile a kernel remaining that may get built into your kernel. So make sure you do the make clean. And then you make a BZ image, which is actually building the image of the kernel. We then move it into place, change the symbolic link to point to the new kernel that we've compiled, and then we cross our fingers, well, it's make modules, which is the loadable stuff, and then we cross our fingers and reboot. If it doesn't start, we've got a problem, but we can boot off the USB, so if you've got a bootable USB, boot into single user mode, boot into single user mode, and point the link back to the previous version of the kernel, right, which means you can recover your system. Right, and then there's just a way of modifying. Alright, chances are you will get compilation errors. So again, you make clean and make dist clean, which is distribution clean, which cleans out and makes sure that there are no other files that are floating around. Other things, again, this is to do with the dependencies. You might be having missing libraries, so there's a hint there on how to check that. Let's go to the next one, we don't need that. Alright, another joke, because you guys have got such a great sense of humour. I'll read it to you later, Sindel. It's a very common one about PEBCAT. Yeah. Okay, so I've got to move along a bit quicker. User management, we'll go through this fairly quickly. You can have a read through it. It's fairly straightforward. But really what we want to get across here is there are two sides to the user management. The first part is the technical, and the geeky bit we all like, right? Playing with the setup, configuring things, making sure they work, doing a bit of testing, making it run as quickly as we can. But the other side is the human side, and this is really the big part. And this is what will get you a job or not get you a job. If you can't deal with people, you're in the wrong place, right? It's not just a technology. If you're a system administrator, you have to deal with people all the time. You have to keep people happy. Remember, you are there to help them do their job. You are not there to build your empire and control a wonderful networking system. All right, so it's about the human interface in a large number of ways. Some of the technical things we have is the accounting, making up new user accounts, registering new users. And also remember that generally in system administration, it's not just the computers you're looking after. In medium-sized businesses, you will also look after security systems, telephones, fire alarms, anything to do with technology that the company's using. All right, so there may be a large amount of administration you have to do on accessing phones and all the rest of it. These are things that we have to deal with, accounting, for comfort and convenience. There's a lot of ethical issues. For example, common one is, if you're the system administrator, can you read users' mail accounts and all the email they receive? The answer is yes, you can. Because if you are the real administrator or root user, you can access anything. Should you access it? Not necessarily. If there's a case where there's an investigation, yes, you should access it, but generally you'll just access it, pull it off, pass it on to the correct person. So there is always this question, when is it ethical to do certain things, like look at users' email accounts? Generally, you shouldn't, and it's also really, really, really boring. but you shouldn't do it. There are the ethical issues on what people can look at and use the equipment for. And that can be something as simple as, well, it's lunchtime, we'll let them go off and play World of Warcraft if they want. But it can be also very complex. So if you're working with lawyers or psychologists or at a university, people might be looking up some very, very disturbing websites, but that is legitimate. All right, so you've got the ethical details of, is it fitting for the work? Is it suitable to allow access? And because you're the person who can say yay or nay as a system administrator, you really have, are in that position to make ethical judgments. Okay. We also have the trust management security aspects, which can be in a large part not technical. Okay. The greatest weakness in any network system, any set of servers, are the users. They're the ones that cause you a problem. They're the ones that let people in. They're the ones that do things wrong. So it becomes very much a human issue. Okay. All right, so one of the first things we need to do is create users. Generally, there are tools for this within whatever operating system you're using, but quite often they don't do what you want to do. They are default. They will do what the operating system vendor thinks you need, which may not necessarily be what you want. So generally, it's not a good idea to use the standard user creation utilities. Under Linux, you really should make your own up, create a script for it. So you create home directories how you like, you give them access to software, groups, etc., how you want, etc. Windows on its own is particularly bad at this, but when you add Active Directory on, you get full control back. And again, it is something you want to build your own system for creating new users. And generally, you would create categories of users. Right? So you would have different types of users. So you'd have, say, as a minimum, executive, middle management, and plebs. You know what plebs are? Plebeians from the Roman time, non-slave citizens, bottom of the pile except for the slaves. So we refer to everyone else as plebs.
Yeah.
All right, so you make up these basic templates for each type of user that you would have, and then you modify them when you create each one. And you can do that with Windows Server, Active Directory, NetWare if you're still stuck with it, and not so much with Unix and Linux, which is why you use the old Apple create your own scripts to create the users. Right. Okay, and you can do that from command line in Windows too. Okay, to create a Unix account, you think up a unique username, user ID. You can allow the system to create these for you, but quite often that's not a good idea, particularly if you are sharing machines within the Unix environment. You want not so much the username to be the same, you want the user ID to be the same. That little number that goes with the user, because that's the number that's associated with different groups. All right, so you may want to actually create this user ID manually. And it isn't as hard as you think. To create an account, all you need to do is add a line to the etc passwords file. You put in the username, you put in the field for the password. You don't actually have to put the password in. The path, there's a couple of date fields which I'll show you in a second. And on the end, the shell that they want to use, sorry, before that, the home directory location. All right. That will create the user, and they'll be able to log in. They won't have a home directory unless you go in and create it, so you make that part of the script. They will have their shell set up. They won't have a password, which you can do within the script itself as well. So you use the password command, PASSWD, because we all hate typing. I told you the reason that all these Linux commands are rather cryptic and short, didn't I? Because Unix was designed by people even older than me, and can't type, same as I can't, and you type with 2 fingers, so you made the commands really short, so you'd have to do lots of typing. And that's the only reason. Okay, so then we can manually go through. If we create a standard .c shell or .profile for bash profile file, we can add that in, and that will give them things like their path and other aspects, terminal type, names of printers, different aliases we happen to be using as a default. Right, so this will make a nice custom created account that suits for your purpose, which the standard user add command won't. Right, okay, so, and this allows you then to set up a proper place for users' home directories, particularly important if you're doing this on a server, which is mostly where we use Unix and Linux. And we might have multiple servers and multiple sets of hard drives that aren't done as proper storage or network attached storage. So we need to actually physically locate them to a particular hard drive, depending on some parameters that we've set up. Yeah, so you can do that manually. If you use a user add, it pretty well defaults to things that the distribution creator wanted to do. Okay, password files. This is the example I was talking about. You can type these in yourself, or get the script to enter them in. Just a straight entry on the text file itself. We have the username followed by the encrypted password, user ID, groups, full name, home directory, and then the shell they're using. It can be a little bit different if we use shadow passwords, which we should use shadow passwords. The passwords themselves are hidden off in a separate file outside etc passwords. Now, this is a very common, simple method of security. If we have 2 steps to get to anything, tell me, Joe.
Was that?
Funny?
Oh, yeah.
Thanks. I'm just embarrassing you because you're laughing. I don't like people laughing because I think they're laughing at me and I'm very insecure.
No.
No, I'm kidding. You couldn't stand up here and do this for 20 years if you're insecure. Okay, so by moving things off 1 step, it aids with the security. If we get access to the password file, which is really, really easy because everyone has to be able to read the password file, otherwise they can't confirm their own password to log in. So everyone can read it, which means you can get other people's encrypted passwords, which means you can decrypt them. So if we just point to another file, which people don't have the same level of rights to, it means you have to access the password file. That then just points off to another location. And you have to have the rights to get to that secondary location to be able to pick up the passwords. So by removing it 1 step, you're increasing your security. Okay, really key thing in all system administration is groups, user groups. I've said this before. When you are creating any service, any resource on your server system, be it Linux, Windows, Mac, whatever, create it in groups. So you get a new printer, you put this new printer in, you create a group for that printer. And then you add that group ID to users who need it. So you just add these users into that group. Right? And you can have a look at the groups file in etc again, because that's where all that config is. And you'll see that these groups are there and who is a user within that group. It's just a straight text file. I've got one on the next page. Okay, so you put in a new printer. Bill comes along, says I need access to that printer. You just add Bill to that group. Bill leaves, and you just remove Bill account from that group. Okay, so it makes your life as an administrator much easier. Okay, so groups are defined statically by the system administrator. There's by default a users group, which is all users, so everyone belongs to that one. In this case here, it's 100. There is a root group, which you shouldn't use for anything but the root account. Yeah, and all that. So have a look at the groups file. Okay, on your virtual machine or in the notes here. Here is an example one. Oh, hang on, unit groups can go to. Oh yeah. So there's a good example. If everyone who's creating web content, you create a group for www.data, right? That's a group. Anyone who needs to access or edit the web pages belongs to that group. They get rights to access that particular directory. They no longer have need to access that. You just remove them from the group. Right? And it keeps everyone together, so you know that all the people who can access your web directory, your content, are within that one group. Okay, so we've got an example one here. Users is everyone, and it's group number 100. That's interesting here. Oh, it's just an example. So the www-data file has a group number of 501, and it includes the users www, Corio, Mart, Greece, Siemens, etc. Oh, and you'll notice there's other users in here, like MySQL, because MySQL will have to be able to access that same web data for the SQL queries. All right. Okay, they should have account policies as well. As I said, everything is covered by a policy. A big part of the system administrator's job is the administration, like it says. So we need a policy for what the rights are of having an account on the system. Fairly straightforward. Should have what you're allowed to do, what you're not allowed to do, specifications of the enforcement, so what you're going to do to them if they do something wrong, and things like password expiry and length, which we talked about before. Disabling accounts, and this is something, the instructions are all here on how to do it, but the reason we don't delete accounts until some point in the future is quite often you will either need to access the information that is within that account after the person has left, particularly if they leave under a cloud or quit or are disgruntled in some way. It may take time to withdraw all the information. For instance, if they're a salesman, they may have contracts sitting in their account. You need to see which ones are still active, chase it up, pull data off. There may be tax implications or legal implications. You'll need to keep the information for a set period of time. Or the person might actually come back. They may quit and then say, no, I changed my mind, I want to come back. And it's very, very difficult to recreate the account or restore an account from backup. Why is it hard to restore a user account from a backup? Guesses? Yes, Sindel?
Because the information could be lost.
Yeah, it could be. It also takes a very long time if it's on tape. But more importantly, all that configuration stuff about your user password file or your LDAP entries or your Active Directory entries aren't in the backup. So it becomes very difficult to just bring your account back. We see this a lot with the mailboxes and mail accounts, particularly in Exchange. So what we do is we disable accounts for a set period of time. Lots of ways you can do this. In Windows you can go tick on a box and that disables the account. You can remove the shell, which allows them to log in. You just get a blinking cursor that can't do anything. Or other ways, you put in a little script into the EGC password entry and it'll run a little script saying your account has been disabled and then log them out. So it'll allow them to log in, it'll run the script, which is up on the screen at the moment, saying your account has been closed because of this reason, and then log them out again. And there's no way they can actually log in. So there's lots of different ways to do it, but as I said, disabling is the best way to do it rather than deletion. Another one down the bottom there for Linux anyway is you replace the encrypted password with asterisk, because that cannot be a password. A single character can't be decrypted, so there is no password existing. If you leave it as blank, it may allow you to log in without a password. Okay, the environment itself, I think we talked a bit about this before, so we'll cover it very quickly. Dot files are for settings, defaults, information about the file. As I said, under Mac OS, if you look at the dot files that are associated with every other file on the system, it has the metadata in it about the type of file that it's associated with. We've got the .profile and .bashrc, which you can modify to suit what the users want. And again, these files generally start with are fairly simple, but they tend to build up, particularly as users do things or you start to increase the capabilities of the system. So it's best to script these, make sure you recreate them manually, set the path, terminal type, etc. If needed. Okay, we have other environments like the Xsession, XDM, and other windowing managers. Nice thing and bad thing about Unix and Linux is you can have a nice graphical environment. You should have seen, I think they're using KDE or GNOME on Ubuntu nowadays. Anyone know? Okay. Which one? Oh, okay, yeah. But there's lots of different types of desktop environments you can have, which is nice and bad, because some of them are truly awful. Some of the ones that are still used are truly, truly awful. For someone in your situation, Sindel, because they are all different, it means the screen readers won't work with them, so you can't actually access certain window environments. For instance, you can do GNOME because Orca works with GNOME, but you can't actually access KDE very well. Yeah. But you should avoid the graphical interface anyway, it's horrible, accessibility-wise. All right, so here's some pictures of what they look like. These are actually reasonably current ones. They're only a year or two old. This is a standard X environment up on the corner here. It looks really, really boring, but it is very, very efficient. So if you must have, for some unknown reason, a windowing system on your server, something like standard X type windowing managers are useful because they give you that graphical environment, but they are extremely low overhead. They're not very pretty, they're a bit clunky, but they serve a purpose and are very low overhead. So they can be used there. But there's a whole variety of them. One of the worst ones I've ever used is the standard Sun one, now Oracle, CDE, common desktop environment, and it is truly awful. All right, when you're setting these up, you need within your shell script to set up that terminal type. I mentioned this before when we had mainframes and dumb terminals. We used screen addressing, which was unique to each type of terminal. So we need a terminal type for addressing the any graphics we want to use in screen addressing. We need to have a default prompt, right? And as you will see when you start playing around with Cisco routers, the prompt is very important. It gives you lots of information of where you are, what you're doing, and what level you're at. So changing the prompt so it gives you useful information is a good move. All right, and then we can put in alias as well to shorten things. So if we're always using, that's the one I've got there, Emacs for our editor, number one, go and see a priest and get Nexusism because it's evil. But you can actually change it instead of Emacs to be Ed just by using an alias. Has anyone used Emacs? Don't. It's horrible, 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 horrible thing. Very messy. Okay. Oh yeah, and also just for efficiency's sake, when you're setting up your path, make sure you put your path in the order of the likelihood something is going to be there. So you would have, for example, the /bin directory is one of the very first entries in the path, so that it will look there first. Reason we do this is on your local little virtual machine, you're not going to notice any difference. But if you are in a large server environment, some data center, you don't know how far away physically or logically the commands you are typing are. So you want to grab the nice close copy, so you're not searching through all of this path to see if it's there, when the path happens to be the server that's residing in Mulvania running on an old 386. Right? You want to be able to go straight to its correct location. Okay, a little bit more on the root account. Very dangerous. You can give a powerful shell to the root, but you shouldn't use it most of the time. Very important, if you are having a shell for the root account, which is quite normal to do, make sure that the shell is stored physically on the root partition where you're booting. Otherwise, it will start to boot up and you won't be able to log in or do anything, right? Because it won't mount up the other file systems. When there's a problem anyway. Okay, the super user's path should never include dot. What does dot mean in a path? Anyone? Come on, what does dot mean? It means the same thing most of the time when it's on its own. Current directory, yeah. Wherever you are. So if I'm in a FTP directory somewhere and I've got dot in my path, I'm working as root, and somebody had uploaded a fake ls command and I type ls, I will execute that local ls first because the dot is in the path, and that may have malware in it. So when you root, never include dot, never include where in the search path your local directory. It can be a pain because sometimes you actually have to type a full path in to get to the file that you're actually after, but it's much safer. It's okay for users because they shouldn't be able to do anything because they shouldn't have the rights. Other things, root should never run X11, that windowing system, because it's full of holes, very insecure, should never log in directly to a system unless you're in single user mode. Never have your own email, etc. Okay, a bit more on the soft side. I'm going to have to get through this a bit quicker. User support. Now this is the main job you will have. Whether you're a top-level person or an entry-level person, your main job will be user support. Whether it's actually in person or not depends on your level. And you should have a policy in place for this. Do you allow users to support their own machines? Do you allow users to do administrative stuff for you? Well, that very much depends on the type of user you have. If you're in a software engineering company, yes, you would. You would want them to help you out. You would give them freedom. Let them do things that they have to. Keep the policies at the forefront. Make sure they're doing the right thing. Keep an eye on what they're doing. Don't give them too many permissions, but make use of the people to make your job easier. Not only does it make your job easier, they become happier. If you look at machines we have at Curtin, if you're unlucky enough to be on a machine that's supported by kits, it'll be locked down so tight you can barely write your own name in a document. All right? It makes your life really, really hard, and that makes people unhappy. Give people the freedom to do things as they see fit, within reason, they become happier. They complain to you less, right? Which makes you look better to the boss. Makes your life easier too. All right, so do we work self-sufficient or fully supported? Well, normally neither. We do a mix of both. And that, again, as I said, depends very much on the environment you're in. If you're working with a bunch of lawyers, then you probably don't want to let them do anything. You probably even want to take the mouse and keyboard away from them because they don't have a clue what they're doing. If you're working, as I said, with software engineers, you probably want to give them a lot of freedom. If you're working in an environment such as medical records, doctor's surgery, hospital, etc., you want to not give them any rights whatsoever for a very different reason, and that is privacy and security. Medical records, very sensitive, you don't want people getting hands on them, so you don't give the users a great deal of rights or privileges to do anything to their machine, or they can actually get access to information that they shouldn't. All right? But if you make the documents up, you set the policies, you make the policies public, make sure everybody knows about them, you usually have a lot less trouble. People will understand why you're doing these things. Just locking things down and not explaining why is a very bad thing to do. Okay, we've got a couple of different types of users. I won't go through that. We've got active and passive users. Active users are the ones who are actually going to help you out. They can be a pain in the neck, but they can also be very helpful. These are people who have got an interest in the system. They want to know what you're doing. They want to take part in tests and trials and want to have the latest software, etc. But you can use them for testing and other things, so we'll go through that. The other type of users, the passive ones, basically just sit back and take whatever they're given, don't want to know, won't change their own printer cartridges, etc. They are much safer. They will cause you less issues because they won't try anything, but every time a single little problem comes up, you'll have to go out and fix it. The other thing is controlling user resources. Users generally don't chuck out any files. Does everyone here kill off files, clean up their hard drive, save space, all that sort of thing? You do? I don't.
I reinstall the operating system.
Yeah, that's an interesting idea. I must try that one day. Every time my hard drive fills up on my laptop, I buy another laptop with a bigger hard drive. I just migrate everything across. There's a really good reason for that. I only use this for work and patience when I'm really, really bored. And because I work in a university, though, I've got a lot of legal documents on here. And sometimes, and 1 or 2 times it's happened, I've had to go back to emails I received 5 or 6 years ago from a student to address a legal issue that's come up. Right, so I don't actually get rid of anything. And it's all there, it's all sitting there, and I just keep migrating across, and it's always backed up. But users generally will not delete anything. On your system, your wonderful data center that you've got set up with massive amounts of storage, generally if you've got massive amounts of storage, it means either you have masses of data coming in or you have masses of users, which means it all comes back to having little bits of storage, right, for each user. And if they're not going to delete anything, it fills up. So you do need to go through and make policies on what people can store on the drives, right? What is allowable. Are you going to allow them to keep their music collection there? Depends on your application. If you're a radio station, probably a good idea. Right, and enforce strict quotas or other restrictions on the storage. Have scripts that run through and remove files that you don't want to keep. Things like old logs. You'll find that most of the modern services will rotate the logs anyway. So if you have a look at your Linux machines, you'll find that there will quite often be a log.1, log.2, log.3, and log.4, and a log without a dot after it. They rotate. So as the first log reaches a time or size limitation, it copies it across to log.1, log.1 gets copied to log.2, until we get to the end one and that gets deleted. Right, so it'll keep a length of logs, but it'll wipe them out over time. But in some cases, systems don't do that, and the log files just get bigger and bigger and bigger. So you need to run through and clean them up. I run UNIX on my Mac to kill off log files. So if you're running a Mac, UNIX is a really good automated way to do it, because some of the log files can get really, really big. And the same in Linux, same in Windows, etc. You will have policy on MP3s and videos and those sort of things. If you have a policy that they're not allowed to keep them, then you set a script and go through and delete them. And core dumps and error files also happen. So you want to get rid of those. Also on the maintenance side, we want to kill off old processes, things that become zombies, hung, using memory. Occasionally we want to restart, kill off and restart things as well. All right, so we need to keep an eye on what's happening with the processes. We can do that using either PS or top, running awk, grep, etc. over the top of them. Have a look at the output. If something is increasing in memory or using too much CPU, which is at the definition of course, or sitting there never using any CPU, you might want to be able to kill it off and restart it. Right, and that's a very important thing to be keeping an eye on. I think it was in the lecture Naz gave you, one of the best monitoring tools I've ever had the pleasure to use was under Novell Network. And it was just a screen with a block, like a snake that moved around. And the longer the tail, the more CPU usage you had. And that was it. And you could be walking past a bank of servers and just look across the screensaver and go, problem there. So very simple, very primitive, but it worked very, very well. There's no reason you couldn't write a little script to do that yourself, looking at the CPU usage overall, and adjust the tail length on a snake moving across the screen using ncursors, which is the screen addressing library for command line, and you could write your own to do that. And it's a nice, easy visual way to see what the machine's up to. Okay, so you want to look at the background programs that crash or hang, get rid of those, restart them if need be. And example there, not a very good one. If you've got a policy that you restart machines every so often, look for processes that have been running for a certain period of time, shut them down and restart them. Okay, so there's just a script on getting rid of old users when you want to actually delete them. There's a lot to do. You need to remove the account entry from password database, because remember, the right way to create the account is not to use user add, which means you can't use user del, but to create your own script to create user accounts exactly as you want them. All right? So you have to go in reverse order. So either create a script to remove the password entry, get rid of the personal files, deactivate mail account, get rid of their access to the shared files, get rid of their access to printers, that are 20 other things that you've done. So either have a script or use LDAP or Active Directory or NDS or whatever your company happens to be using, and create your accounts through that. Do not use the default account creation. Okay, more on the policy, computer usage. I think we've covered enough on that. Lots of policies. The interesting one, of course, there is the policy with the risk of using old, insecure operating systems. Now, again, was that... I showed you somewhere, it's probably back in the network operating systems. Operating systems don't go away. Your home machine, because you're probably a little bit techie and you're interested, is most likely the most up-to-date thing that you can get. Right? Everyone here is running Windows 10 or Mac OS, whatever the latest one is. Sierra? No.
Yes, it is.
Sierra. Yeah.
Yes.
So everyone's running those operating systems?
Yep.
Right? That's techie people. Go into business, and there is very, very good reason not to change. One of the largest banks, I think it was a Commonwealth Bank, only changed from XP to Windows 7 last year. Why? Because their systems worked with XP. Changing to an unknown operating system was a major high-risk venture for a bank.
I'm pretty sure I heard some banks still use OS 2 from IBM.
Yeah, that was around for a long time, and that died in the 80s. 90s. 90s?
I think it was 90s.
Yeah.
90s.
Yeah, I always took it. It was a good operating system. Very good operating system. Bit clunky, but I liked it. So you'll find that in a lot of instances, operating systems don't go away. We have I hate saying this, a test rig for mechanical engineers called the ball dropper. And all it does is drop a steel ball bearing through a viscous fluid that's being stirred. All right? And it costs a lot of money to set this up. It's very accurate. It's got lasers that fire through the viscous, it's clear viscous liquid, and it measures the speed and deflection of particles falling through this vat. I actually built it back in the electronics for it back in 99, I think. And at the time, Windows 98 was the operating system of choice. that machine is still running and still running on Windows 98 because nobody has gone around and updated the software because there's no need. So here we have a system that is antique, ancient, still in use because of a particular piece of equipment that it runs. They don't go away. So if you're in an environment, could be medical, could be engineering, something else, mining, where they have this antiquated equipment, you need to have policies in place to look after how do we take care of these very insecure old operating systems. And what we did with that particular Windows 98 machine is we took the network card out and bolted the case shut. So you can't connect to the network, can't do any real harm. Someone can break it, destroy it, whatever, but it can't cause any real harm. Okay, and I'll put an example policy on Blackboard for that. So have a look, and it'll be, keep a copy, it's useful for later in life. Okay, I'm going to go through that. So I'm going to skip over these because I need to go through the disaster recovery simply because you're going to need that in the assignment which is due very soon again, remember. So read those slides and have it. One of the key things that you'll be doing as a system administrator is change management. Who's familiar with change management and the process of change management? Nobody? Okay, there's big HR policies and procedures in place in every large organisation on managing change. People don't like change. People hate change. It causes major disruptions. It gets employees very, very upset, angry and insecure. So it's not nice. We're going through yet another change management here where we become the... have you heard about this, as students? Change of school? Okay. You know, at the moment we're the School of Electrical Engineering and Computing. We're about to become the school of everything that doesn't fit anywhere else. So we're going to be the School of Electrical Engineering, Electronic Engineering, Computer Systems Engineering, Computer Science, Physics and Maths, and Astronomy, and Intelligent Computations, and a few other things. So really important to the school. But by changing that, it's really getting people nervous and upset. They don't know if they're going to have jobs, etc. Yeah, nobody likes change. So when we're looking at changing over from our Windows 98 system to something really up-to-date like XP, it's going to upset people. And you have to have a system of change management in place so that people don't get too upset. They don't fight against you every step of the way. Right? So we had this a lot with the change from XP to anything else. XP worked. I actually admit I didn't mind XP too much. I didn't think it was too bad. And I haven't touched Windows 7, Windows 8 or Windows 10 at all. Hate it. Try it every now and again and just give up. But I don't like the change from XP, so I didn't. I can. And nobody really likes change. So we've got to have a process where we can bring people along with us. And when you're doing major changes in your IT infrastructure, you have to get people on side, explain to them why you want to make these changes, and how you're going to make these changes, what effect it's going to have on them. Normally we have two ways of doing it: deconstruction followed by reconstruction. Blow everything up, wipe it all, start again. And that's the preferable way for most people because it means you've got a clean start. If you can go to every machine and just throw the machine out, bring in new machines already installed with Windows 10, it's much easier. Yeah? You want to upgrade your old machines to Windows 10, you've got to make sure they've got processing power, the right amount of hard drive, right amount of memory, and all the other things. This is going to run the software that you want, etc. So much easier to get rid of it and start again. But that's normally not possible. So in large networks, we normally do it in a progressive manner, differential changes, and slowly bring things up to speed. So as machines come out of lease, you would replace them with new machines. You would only update systems that were capable of it and leave the others alone, etc. Yep. Okay. So you've really got to explain why. So if someone tries to explain to me why would I go from Windows XP to Windows Vista? Oh, there's a good argument. Convince someone to go from Windows XP to Vista. Yeah, nobody can. I wonder what happened to that. We had the original Surface sitting here. I have to find out what we did with it. And that ran Vista, which means it didn't run very often at all. But the only thing it was ever used for was a coffee table. $20,000 that thing cost. Yeah, I don't even know where it's gone. Anyway, so you've got to make a reason for it. Why am I going to change from XP to Windows 10? because XP is no longer supported, it's insecure, it can't handle the new programs, it'll be much nicer, much faster, easier to use, etc. And bring people on board with that. You've got temporary redundancy of a service, sensible thing to do. So if you're upgrading your servers to a new version of Windows Server, keep the old ones running. Or at least put them on a second-rate machine, something old, slow, but there, running in the background so you can always switch back. Because the chances of everything working 100% first time you switch over, it's pretty slim. It's just the reality of life. Right, so have some redundancy in place. And overall, your change management can be viewed as risk management. All right, it's a risk of it not working, it's a risk of users not accepting it, and what you've got to do is reduce the exposure to risk or the impact of that risk. Anyone here a scout? Scout leader? Been a scout? No? Good. Well, I was a scout leader. I've been a Joey, Venturer, Cub, Scout, and then back to Cub again for the next lot of kids. So, good stuff. But the poor old leaders have to do risk assessment on everything. And basically it is just, is there a chance that little Jimmy here will fall off the slide? No, because we'll rope him up at the top and he won't be able to move. And if there is a chance, what do we do to reduce mitigation? We're going to put mattresses under the slide. Right, so it's a case of looking at everything that can possibly go wrong and saying what is the likelihood of that and what is the impact of that. So anything that's got a very, very high chance of happening, you have to have a contingency plan for. If something has a very, very low likelihood of happening, then perhaps, depending on how risky it is, you may or may not do anything about it. It's just an acceptable risk. And all of the change management is based around that. If we change over to Windows 10, what's going to happen? Word will work, yeah, we know that. But what about this custom software that we run our business on? It's the main core of our business that we run this software. Have we tested it with Windows 10? Yeah, it sort of worked. Most things worked, was okay. If we can't run that, we're going to go broke. So in other words, you don't do it, you test it, and you do more testing to reduce the risk of something going wrong. What if users don't know how to use Windows 10? Right, they're going to look like fools in front of our customers. Well, in that case, to reduce that risk, we spend more money on training until the risk balances the benefit. Right? And again, that's very, very important in how you must do things. Okay. All right, and there's just a bit more on change management, what we should do. Clock synchronization, and we'll leave those. All right, you can have a read through those automation of configurations. It's very, very technology dependent, so probably not worth going through too much, but there are lots of packages that will help you manage your systems. This is the key one I wanted to get through today, and we're all caught up then, and that's on disaster recovery. Disaster recovery is something that is very, very, very important. You hope you will never have to actually use. It's a task that is normally thrown at the least senior person in the organisation because everyone hates doing it. And if disaster recovery doesn't work properly, the person who wrote it's in a lot of trouble. So high responsibility and not very nice. So it's probably one of the things you will have to do fairly early on, and if you don't do it fairly early on, you should make sure you have a disaster recovery plan in place and you think it works. So here we go. You're the IT manager and you get a call at 3 o'clock in the morning. When you get to work, what do you see? Flames leaking out of the upper story windows of your office, and you happen to have all of your servers and gear stored and working in that particular floor. A little bit unpleasant. If it happens at Kernel, all we have is lots of academic staff throwing petrol on the fire, hoping we can all go home, but generally in a real business they won't do that, and they'll be upset that things have caught fire. Okay, so the fire brigade leaves and you get into your server rooms, and what do you see? A big lump of melted metal and not any plastic left because that's evaporated. Nothing is really recoverable. With smoke damage, that'll wreck most machines. Water damage will definitely kill the machines, and if it doesn't kill them straight away, it'll kill them fairly quickly. And your business is reliant completely on your IT infrastructure. You might be running a web business or a design business or something along those lines. So we're in a bit of trouble. But luckily, we've written a disaster recovery plan. And this is something you do along with your normal troubleshooting and other things. You have a plan for when things go catastrophically wrong. as I said, you hope they never will, but the chances are at least once in your lifetime you will have to do something along these lines. Main areas to consider is the server data could be threatened. So if you do have a disaster, where is your data going to be stored? Is it going to be recoverable? How are you going to get it back, and how are you going to get the servers up and running? We need to identify both common and uncommon threats. And again, this is along the lines of that risk management we were just talking about. The chances of your server being struck by lightning are higher than you think, but not significant. So do we take precautions against lightning strike? Well, yes, we do, because it's very cheap. We stick a metal pole on the roof and we earth it. So we get rid of that. The chance of us having a fire run through this building, very low. But what do? We have fire extinguishers and fire sensors in place so that we can look after that. All right, so we look at the risk and we look at the expense of preventing it or reducing the impact of it compared to the cost of that service failing. So, no, I won't get into that just yet. All right, so we identify the common and uncommon things that can affect your network or your services and the measures we need to take. Okay, your disaster recovery plan identifies the steps that we need to do to recover from this list of things. Now, disaster recovery can take many forms. It is not necessarily physical damage to your servers, fire going through, or someone stealing all your data, hackers getting in, that sort of thing. It can be loss of a key employee. Right? And I know of situations where the system administrator is the only person who has the administrative passwords to the entire IT system. And this is for a medical research lab, which is really, really silly that they can do that. All right, so that person leaves, no more passwords. How are you going to get in? Right, that's a disaster recovery case. The company's not able to access its servers. Going to become more and more common with cloud-based systems. We have a rogue country where the servers happen to be because they're really cheap to store them there, and they cut off connection to your servers, decide not going to deal with your particular country, or they go broke. More common thing to happen. Right, so wherever your servers are, company goes broke, people come in, repossess all the equipment, your data goes with it. Problem. Information on the network is lost, it's piped out to dead null, or drive crashes, realistic. Your office building is destroyed, or commonly your data is corrupted. Something happens, it gets corrupted, you have a power failure and a piece of data is corrupted, so how are you going to get back from that? The servers themselves are vulnerable to lots and lots of threats. We've got hackers, natural disasters, decay, the system slowly winds down. By the way, did anyone get that scam email that somebody's accessed your camera on your computer and they're going to send personal photos of you to all of your contacts?
Even if I did, that would work because I'll take my camera and
Yeah, I went through Notre Dame Uni yesterday. Hundreds of students got hit with this and there was a lot of very upset people. Yeah. It was really badly written too. Don't know how anyone could believe it. Fall for it. Just out of interest, and they said Curtin got hit as well. Okay, so hacking real problem, and we've got to be able to build something to recover that. Okay, so your leading causes of data loss, hardware or system malfunction, hard drive fails, really, really common. Hard drives will fail, full stop, the end. Okay, it's just a question of when. Anyone know the lifespan of a server hard drive, very roughly? What would you expect to get out of one?
5 years.
You're pushing it. I reckon 2. Heavy use server, a couple of years and they can put. But yeah, okay, 5 years could be for a really good drive. But you know they're going to fail. So you're going to have to either replace them on a regular basis or whatever. So it's mentioned somewhere else. Mitigation there, what do? Is you keep a stock of hard drives and match your system. So when one fails, you just whip it out, plug a new one in and off you go again. Make them hot swappable so you can plug them in while the machine's running. Running RAID 5, it'll rebuild the data from the redundancy. Human error, almost as high. RM minus RF star, oops, common. So people make mistakes and kill things off. How many times have you deleted a file that you were working on and there it is gone, you have to start over again? Everyone should have done it, I expect.
I accidentally formatted an SD card once that had files that had been backed up, so
Yeah. Common, really common. All right, but if you backed everything up, you'd be safe. If you could find your backup.
Yeah, I did, but then I deleted the backup.
Yeah, it's like that. I became absolutely paranoid about that when I was doing my PhD and kept so many copies of my thesis that I had trouble tracking which was the latest. So you can overdo it as well. Okay, software malfunction, not that common, but it does happen. Word crashes. Again, my thesis, I made the mistake of trying to write my PhD thesis in Word, and Word can't handle large documents. And it kept crashing, and I was losing stuff all the time. So software malfunction isn't that uncommon. Virus is surprisingly fairly uncommon, right? Because people tend to take security of their systems fairly seriously in a corporate environment, and we're fairly careful, so the viruses don't do too much. And natural disasters down at 3%, which is really, really tiny. But natural disasters tend to be really, really catastrophic. So cyclones, fire, flood. If you get a flood that hits your server room, everything's gone, kaput, finished. All right, it's all gone completely. So natural disasters, even though this is a fairly low likelihood of it happening, it is usually catastrophic. Whereas hardware malfunction, very, very common, but normally not that serious, if you're doing the right things. Okay, it's fairly common stuff on here. We're increasing our vulnerability. Everyone's becoming more reliant on IT. Paper records, very rarely kept nowadays. You guys do tax returns and things. Do you keep paper copies? No, everything's electronic. I run a couple of, on the board of a couple of charities. We no longer keep any board documents in paper form. They're all electronic. And if you lose those, then of course you can't keep operating. Okay, the systems themselves are becoming more complex. We're starting to tie lots of other things in together. So no longer do we just have computers doing the accounting or computers doing the payroll or the stock control, that sort of thing. Everything's becoming interconnected. So if you lose one part of the system, you tend to lose more than one part. So the entire system goes down just because one part goes out. With the Internet of Things starting to take hold, one thing goes wrong, and because it's all interconnected with your chain of your supply chain, your manufacturing, your payment, your orders, everything tied together, one part goes out, the whole lot goes. So becoming a little bit more vulnerable in that way. Okay, a greater number of employees have been given access to stuff. Generally, if you just look at a store person somewhere, they've usually got a fairly reasonable level of access to the inventory stock control price list, and they can change things either vindictively or accidentally and affect the systems. Problem is, and this is one thing that you will have difficulty doing both in the real situation and in the assignment, how do you put a value on that data? Right, so you've lost all of your data for your business. Right? It might be backed up, you're going to recover. But how much is that data worth? And what is it costing you for every hour you can't access it? So we look at an extreme example. You're running a online business, web store. Your normal sales are $10,000 an hour. Your database, your IT system is gone. It is costing you $10,000 an hour. That's what it's actually costing you because you're not getting those sales. Moreover, people are going to go to your web store and go, it's not available, go somewhere else and buy it. So you will have long-term damage as well. Right, so you've got to be able to put a value on it. That one's fairly straightforward. But if you're, say, a university, what is the value of our data? How do you put a figure on that? If we lose all of our student data from some major disaster, does it cost us anything straight away? Probably not for a little while, as long as we're assuming that we can recover everything. In a week, it's probably going to cost us a lot in our reputation. 2 or 3 weeks, it's going to cost us a huge amount, particularly if we start to come up to examinations and graduations and upset students and staff unable to enter marks. Right? So it starts to cost us money because we're going to have to do that at a later stage. There's going to be wages. If we can't recover it, we're basically out of business. How long to go out of business? Not very long, I wouldn't expect. Right? But this is something very hard to quantify. And when you're with your manager, finance person, CFO, whatever, and you're saying you want to spend $100,000 on this disaster recovery plan and the equipment you need for it, he's going to ask you, well, where are we going to get that $100,000 from? right? What justifies that expenditure? And you can say, we're a web business, we're a web store, $10,000 an hour it'll lose immediately, plus the long-term damage. And this will get us up and running in a short amount of time, which justifies that $100,000. So you've got to be able to put a dollar value on basically everything in business now, unfortunately, to justify the expenditure so that you can have your disaster recovery plan fully equipped and fully implemented. And that's very, very difficult to do. Okay, some of the things we can do to mitigate some possible problems. Again, because we're interested in data, we can mirror or duplex hard drives. This is just where you have two hard drives, and whenever you write to one, you write to the other. Keeps exactly the same information on both drives. We can implement hot swappable servers. We've got that in here with our 4-server system. We can actually replicate those across, and we have a little replication bit later on here. And we can unplug one of those servers and plug another one in, and without powering the rest of it down. That big old clunky server at the back has hot swappable power supplies, really well designed because it's designed so that it needs 2 power supplies to run, and yet you can still pull one out and change it with another one, except the power's off when you do that. Yeah, bad design. Server clustering, very common now, so we set up clouds, again, same thing as we've got in there. Keep a stock of hard drives and other common equipment that fails, so you can quickly change things over. Keep replicated server off-site. Right, so we have another server, we keep replicating data off somewhere else. So if we have physical damage, natural disaster, fire, whatever here, we've got a server that's running things somewhere else. Okay, so when you're developing your disaster recovery plan, and remember you need one in the assignment. Happy to look through assignments as well if you want me to look at them. Right, so we have to predefine some of the conditions that will happen. Some things are common, some things aren't. Depends also on location, very important. In Australia, bushfires are fairly common. In northern Canada, they're probably pretty unlikely. Tornadoes in the Midwest and hurricanes in Florida, cyclones in Perth, not going to happen often. Actually, you probably haven't had one in your lifetime here. We had some beauties back in the 70s. Cyclones came all the way down to Perth. Fun. All right, so we identify things that are common, things that are localised, and make plans for those. We need to identify all of the decision makers. Right? When you invoke, and I'll just talk about this and we're going to skip through the slides. When you invoke a disaster recovery plan, you as a system administrator probably aren't authorised to do that. You would have to go to the management. So you have to identify who gives the go-ahead to implement the disaster recovery plan. That's because it's going to be expensive, it's going to be time-consuming, and it's going to be disruptive. If you decide we've got a failing hard drive, let's invoke the disaster recovery plan and replace everything, right? Silly move. That's going to cost you a lot of money. It's not going to achieve much, not worth it. It should just fix the faulty hard drive. So you need to know who has the responsibility to give the go-ahead to actually invoke the recovery plan. We need to know who's going to do what as well. What each person's roles are going to be, both before, during and after the implementation of the recovery plan. Okay, we've got to identify the resources that are required to bring the system back up online. Okay, and there's multiple ways of doing this. You might have a disaster recovery plan that will get you limping along, barely running, but very, very quickly, and then you'll slowly build the system back up to its full operational power. That might suit your particular business application. It might be that you need to get everything up and running as per the way it was before you can actually become live again. And that's dependent, again, on what you're doing, what your business is. You need to prioritise what you're doing as well. If you're running that web business, you've got this online store, is your payroll terribly important? No, because if you don't get that store up and running really, really quickly, there'll be nobody left to pay, so there's no point in having a payroll system. So prioritise everything you're bringing them up that you want to power up again or get running. Do it in the order of that priority so that you can recover as quickly as you can for the things that matter. And worry about the lesser important things like your payroll, which may seem important to you but isn't important in the sense of business. Get to that when you can. Okay, you should organise the recovery plan into something that's flexible, easily maintained, easily readable, and people can follow the implementation plan quite well. Very, very important, validate your recovery plan by conducting simulations on the real equipment. Okay, so there's no point in having a recovery plan unless you test it, because if you don't test it, you don't know if it's going to work. And if it doesn't work, then you're stuck in the disaster mode, and that's not good. All right, so you should test it, and test it properly. A good plan should provide for the safety and well-being of the people on the premises. It must include that as well. Place is burning down, and if your disaster recovery plan says run inside with fire extinguishers, it's not particularly good. So you've got to have the health and safety side in there as well. The key part is to be able to continue your critical business operations. Not have everything running perfectly, not to get everything up and running as quickly as possible, but to have your critical systems available back as soon as you can. Right? So back in operation, even if you're just limping along. Right? It may be a case that you can limp along, that will reduce your expenditure on your disaster recovery plan, therefore it's worth going down that path. In other cases, it's not true. Right? We want to minimise the duration of outages, want to minimise immediate loss and damage. Succession plans. We should always have succession plans built into the disaster recovery, because what if the boss is inside the building when it bursts into flames? Well, actually, that's not the main one. The boss may be on holidays. So you need a succession plan. If somebody is not available, not contactable, you need somebody to take on those roles. So you need a hierarchy of people responsible within the organisation. You need to be able to coordinate the recovery tasks. Generally, it will take more than one person. You need to know what each one of these people is doing so that you can actually collaborate and get on with things in the right order at the best possible pace. So you need to know who is doing what and set up a schedule of the order of things that you're going to do. Okay, so we already talked about this. This is the cost of data loss. IBM reported that 50% of companies that lose critical business systems for 10 or more days never recover. So if you lose data for 10 or more days, you're not going to get out of it. An idea for some of the types of business and the cost of data loss. If we look at banking, the average length of data loss for them to actually go broke, right, this is putting somebody out of business, for a bank is only 2 days. So if you can't fully recover your systems within 2 days and you're a bank, that's it, you're out of business. And then we go down to things like insurance. You can last 5.5 days without your systems. So this is not a terribly long time. If you consider that you've got a data center and it's burned to the ground, you've got to get it up and running in under a week. So it's a serious thing that is not that easy to achieve. All right, I think we went through that one. Okay, the disaster recovery plan itself, it's a set of policies basically. Policies and procedure. Little word on policy and procedure. Policies are things that describe the ideal or the meaning behind something. So your policy should be something that's not going to change very often. It is our policy at Curtin to allow students who meet the entry requirement to study no matter what their race, colour, creed, physical disabilities, skin colour, anything, right? So that's a policy. That doesn't actually tell us how we do that, right? That goes into procedure. That policy isn't going to change. Everybody is allowed to come here and study if they meet the entry requirements. How we get people in goes into procedures, and that changes. At the moment we've got an ATAR minimum of 70. That may go up to 80, it may go down to 65, it may go up to 90, right? It changes. So that goes into the procedures. And it's exactly the same with your disaster recovery plan. You have a set of policies which are the high level statements of what we want to achieve. So if we start with, we want to get back up and running again, and the priority items that we need to have running is our web store, followed by our stock control, followed by our creditor system, followed by our debtor system, followed by payroll. Right? High level policy. Then you would have instructions on how to do that, and that's in the implementation side. So start with your policy, this is what we want to achieve, then you go through your procedures. Policy doesn't change, procedure updates quite often. Okay? We should have recovery objectives. Now this again is in the policy. So how long can we run and survive if our systems are no longer available? And that is very dependent on the kind of business you're in. Okay, you've also got the decision, how long can I survive before I have to invoke this disaster recovery? Is it something we can do without actually going to the full recovery mode. There are several points that we can recover to. Now, we've got a live system, we've got our web store going. And this web store is processing away, taking orders, billing people, etc., etc. At some point, the place burns down. What point do we recover to? Do we recover to the moment it caught fire with zero data loss? Can we recover to that point? Is it affordable within your disaster recovery plan to build a system in that would allow you to get all of your data back with no loss? Or perhaps we're running a spare parts business, right? And the whole place burns down. Do we have to recover that day's sales? No, because the money burned in there, the stock's already burnt, really doesn't matter a great deal. But what we do need to know is from the close of business yesterday, how much cash did we have, what have we sold, what's come out of stock, so what stock is still left there in the ashes, right? So we go back to into the previous day perhaps, that might suit. And that makes it much cheaper to implement our disaster recovery plan because we just need to do a backup every night, move that off site, that burns down, well, we rebuild everything, restore from that backup, and then we're back to where we were midnight last night. Right? So that would work in some circumstances. We could do start of the next business day if you do overnight processing, points during the day, but again, it depends totally on the type of business you're involved in. Right? So you would then set up where you want to recover to. That's the first point. We need to work out what the maximum tolerable outage time is. This is what we've been talking about with how long until the loss will make you go broke. Let's skip over that one. You've got to do the plan in a collaborative manner through different groups of people. You've got your local system administrators. They're going to be the ones implementing it. But you can't implement your disaster recovery plan if you don't have the assistance of vendors, the people who are going to supply the equipment you need to rebuild your systems. So you work with your vendors to say, right, I have this mission critical system. What parts are you going to keep in stock for me? Because generally when you're in a real environment, you don't go and buy one of these no-name rack mount servers sitting over here because they're crappy, you never get another part to fix them, you don't know whether the software you have installed will work on other machines. Right, you go to a reputable supplier who says scoffing Dell, but Dell will guarantee that you can get parts for your server for X number of years. They will guarantee if something in it fails, they will get a part to you within X number of hours. If you've got a contract where they're actually going to fix it for you, they will guarantee they will come out and fix it within X number of hours. All right, so it may be absolute junk equipment technically, but it has a support in place so that if something goes wrong, we know how long it's going to take to fix it. And you pay lots of money for that. Because Dell equipment's not good, it's not cheap, but it's well supported. Right? And again, this is how you work with your vendors. And of course you have to work with your management because they're the ones who are going to go give you the okay to invoke your disaster recovery plan. They're the ones who are going to fund your disaster recovery plan and decide even if the business is going to keep running. Okay, so we need to keep, to be able to do this, a complete list of the individuals responsible for the disaster recovery, and that includes the people who are going to get permission for it, critical list of hardware and software that you need, and again, has to be stored off-site. Right? If it's in the server room and the server room burns down, it's not going to do you much good. And of course, detailed instructions on how to reconstruct everything. Okay, so components include things I've just said, but you must prioritise that material as well. So what is absolutely critical to recovery, what is nice to have, and what can be left until much later. The level of detail as a minimum is listed here. You can read through that. It's basically the details of what you've got to do. Remembering that the order is normally very important. Okay, other services may require services to be up prior to them running. So if you've got a separate MySQL or Microsoft SQL type server set up, you will need that up and running before you get your web store up and running, right? Because SQL handles the web store. Okay, should you include things like the installing of operating systems or restoring a database? No, you shouldn't in this case, most of the time. because these are things that you would do anyway. Normally, it's run of the mill. It's not part of the disaster recovery, it's part of everyday operations. And they're two separate things. So yes, you would probably use them within the disaster recovery, but do you include them in the disaster recovery plan? No, because you're going to install operating systems, you're going to maintain your software, and you're going to do these normal everyday things all of the time. So that belongs somewhere else, in the normal day-to-day procedures. The disaster recovery plan needs only to reference them, so when you go to your disaster recovery plan, it says reinstall operating systems, see the book on the shelf over in the corner. So it references where you're going to do, or where you get the information from. Okay, testing, as I mentioned, is really important. It verifies the effectiveness of the documentation. It verifies how long it's going to take you to recover. It verifies if your timescales are achievable. You might tell the boss, yes, I can get this up and running in an hour, and it's actually going to take you 3 weeks. Right? Running through the test will tell you whether you're right or not. It will also identify improvements you need to make on the disaster recovery plan. The common mistakes we have in this is actually not testing things properly, or only testing things you're comfortable with. When you do a disaster recovery plan test, you must actually test. And I don't mean burn the server room down. I mean you switch the servers off, right, even though it means an outage on your business. You then rebuild the servers somehow, either virtually or through backup equipment or whatever you have. Power that up and see if it actually works in the same manner as the system you're trying to recover from, or recover to. Okay, the common mistakes again, trying to achieve too much too soon, and not doing proper testing. Okay, disaster recovery plans require maintenance. They aren't static. You change things within your environment. And when you change things in the environment, you must update your disaster recovery plan. Because if you have outdated instructions within the plan, then you're not going to be able to recover correctly. Right, so it's a living document. You've got to keep it up to date. Yeah. Okay, there's a good set of examples that I pulled down from this DRJ site of different sorts of recovery plans, different sorts of emergency procedures, so they're worth having a look up as well. Okay. The last little bit that we have to look at is the backups themselves. Now, we can quickly run through this now. Yeah, we can run through this now. Making backups is really important. We've covered a lot of this already and we've talked about it. Basically, we want to decide what we want to back up, what is worth backing up, what is not worth backing up, because they do take time. We need to know how large they'll be so that we select the correct technology to do our backup. Backing up to the cloud is not a viable option in most cases because, number one, network speed, network cost, time involved in backing up, and it's particularly with large volumes of data. If you're in a business that has small amounts of data, yes, that can actually work. But again, we come across that problem. Where is it being backed up to? Who has the, what legal jurisdiction does it come under? Is your data sensitive? Are you actually going to be able to recover it if this cloud company goes out of business? When should we do backups? Now, this can be rather tricky. If you're in like most businesses, they tend to be running 24/7 nowadays because you've got a web presence and you're trying to sell things. When do you run a backup? Right? Because generally, when you think of your backup, what you want to do is stop and freeze the system and say, right, at 5 p.m. on this Friday, I know I have a copy of everything as it was at 5 p.m. on this Friday. If your system is continuously being used, you start doing a backup. At what point are you saving all the files? Your backup may take 5 or 10 hours to run, right, which is reasonably common. One of my early jobs was doing the backups on a AWA reality system, Australian built piece of junk that it was, and it would take 6 hours to back up about 300 megabytes, right? So really slow. But we had to stop users from using the system during that time because if we didn't, we wouldn't know what state we're backing up at. So when we restored, we're restoring back to an unknown state, and that is the worst thing we can ever do. Remember, as system administrators, what we want is stability, predictability. We want to know what state things are in, and we want to know what they're going to do in the near future. If we start doing backups and we don't know what state the machine is in, we're going to restore it back into an unknown state, and that's not nice. That's not what we want. We want things in a known state. Okay? So knowing when to schedule the backups very important. Who's going to do them is really important too, because nobody wants to. How often are you going to test them? I told you that story about someone who did backups, weren't actually working, the system went to restore and there was nothing there. All right? So make sure you test them. How are you going to restore them? How fast can you restore the information? What information can you restore? As I mentioned with email mailboxes, under Exchange they are incredibly hard to restore a single mailbox, right? Just because of the way Microsoft have built the database to store them. So how are you going to restore stuff, and what are you going to actually be able to restore? Okay, many different types of backup, which we'll go through individually. There's an archive bit in most file systems that just states that this file hasn't been backed up. When you back it up, it resets the bit, and that's used in the different types of backups that we use. So different types of backups are here. We've got a full backup, that's exactly what it says, backs everything up onto tape, hard drive, whatever it happens to be, what media you're using. We have a copy, which copies selected parts, right? Now, copy is normally what you do when you back up to USB. By the way, with USB drives becoming so big, are they a worthwhile backup media? Yes, Sindel?
Probably not so, because I wouldn't get a whole certain application and stuff like
Yeah, they may be limited that way. But the real problem with them is they're small and they can get lost. And they're very easily accessed. So probably not. But again, it depends on what you're doing. There's a daily backup. We'll change only files will change that day. Doesn't change the archive bits, so they still remain set if needed. And appended. This is a backup that backs up onto the media until space runs out and then overwrites the newest. And if you use Time Machine on Mac, that's exactly what it does.
that.
All right? It just keeps backing everything up. When it runs out of space, chucks away the old files and keeps writing stuff up there, which is really good for general use type backup for personal machines and what have you. All right, so we also have incremental. Incremental backs up any files that are new or altered since the last full backup. And quite often what you will do is one day a week you will do a full backup. All right, so say on a Monday we'll do a full backup. On day 1, 2, 3, etc., we'll do an incremental backup. All right, and that will just keep things updated. Anyone see the problem with this? It's nice and quick to do because you do one full backup and then for the rest of the week you're just backing up anything that changes. Where's the disadvantage in that? Machine dies, you've got to restore.
You lose the data on Friday and you're backing up on Monday, you lose data for like 4 days.
Well, you would, but that's not what I mean. If we're doing a full backup, then Monday, Tuesday, Wednesday, Thursday, Friday again, Saturday, Sunday, we're doing incrementals. We'll get a change for each one of those days. Right? So anything that's changed will be backed up on those incremental drives. We want to restore. We've got to restore the full backup. Then we add the changes from Monday, then we add the changes from Tuesday, then we add changes from Thursday, Friday, Saturday, Sunday. Right? So we've got to go through all of our backups and restore each one in order to get us back to what we had. So it's rather time consuming. Differential backup. What we do here is we do a full backup on the same day as before, and then we back up any new or modified files afterwards. Okay, which means all we need to do is we do since the last full backup, by the way. So in this case, what we would do is we would do the full backup. We would restore that, and then we only have to go to the last differential backup and restore that one. Right? But the disadvantage here is this differential becomes bigger and bigger as the week goes by, and eventually becomes the same as the full, eventually, long term. Okay, so it just backs up the files that have changed. Okay, we can do image-based backups. This is what you do when you clone a drive. Carbon copy, or what's the old Norton one called? Yeah, what it was. But we just take an exact copy of the drive, so the server hard drive, and we just copy that across to another server hard drive. This is extremely common in having redundant systems. So you would have one system that is your live one, and you just copy everything across to a backup one for recovery purposes. Okay, we can do saves as well. Okay, and then we've got the problems. This is the special types of backup. Yeah. We have open files. These are files that somebody's already working on. When we try to back those up, what copy are we getting? Is it the last copy? If it's a shared document, it could be a copy that's shared by different people. Whose copy are we actually backing up? If it's open, in many cases, we can't read it. The file becomes locked. Right? And when it's locked, the backup application can't read that file either, so it gets skipped. So we've got to have some way of doing open files. Quite often what you'll do is you'll take a snapshot of the file and then back that up. Databases are a real problem because they have that caching rollback journaling system, all right, which means you don't know exactly what state it's in when you do a backup. So you need a system that will actually back that up correctly at a given point in time, or shut the database down, stop people accessing it, do your backup and then restart it. That's a fairly common way of doing things as well. In fact, when you're doing that, normally you would have a replication. So your database would be running on your main server, being replicated off to another server. I'll show you the replication in a sec. You would shut down your main server, back that up at a given time, then roll back to using that server from the replica. So you hand off all of the processing to another identical server at one time, do your backup, so you know at that given time you've done the backup, everything's nicely locked in place and static, and then go back the other. Email, you want to restore single mailboxes becomes a bit of a problem. Mobile systems are very hard to back up even now because when are they connected? Are you going to use your 3G, 4G network to do backup of what may be a large amount of data? That becomes very expensive, in this country anyway. So mobile systems become a bit of an issue. Quite often what you do is not back them up until they're back at base. You sync them when you've got a decent connection. Okay? And bare metal, which is disk imaging. All right, we're going to skip over this bit because we're just about out of time. Picking the type of storage, there's lots of different things you can have, from external hard drives to storage area networks, network attached storage. And we can have a look at some of those others as well. All right, I'll leave the tape rotation that because we're out of time and my voice is gone again. All right, any questions? We'll talk about tape rotation next week if need to be. Yeah, my battery's flat too.